In this lesson, we'll be looking at intersecting lines. But first, let's learn what a linear system is. A linear system, or you might also see it as a system of linear equations, is a set of multiple linear equations. So what that means is that when you're dealing with more than one equation at the same time, that would be a linear system. And to solve a system of linear equations, you would need to find where the lines intersect. So this would be called the point of intersection. So let's look at this first question. It tells us to state the solution for each system of equations. Now we're not given the equations, we're actually just given the graphs here, but if we're looking at A and B, we're looking at the lines A and B. So this is line A, and this is line B. The solution of this linear system would be the point they cross each other, the point where they intersect. So that would be this point right here, and that's the coordinate 5 and 2. Remember, x always goes first, so the coordinate is 5 and 2. And now let's do B and C. So this is line B, this is line C. This point right here is where they intersect, and that's -1 and 6. And let's try A and C. So we know A is right here, line C is right here. This is the point where they would intersect, and that's at -5 and -3. So I want you to go ahead and pause the video, try to fill out all of the other points of intersection for these pairs of lines. So I filled this out as much as I could. For some of them, we had to approximate the point of intersection. So for lines B and D right here, this is where line B is and this is where line D is. It doesn't meet exactly at this point 0, 5. So I just approximated 0.2 and 5.1. And I did the same thing for line A and E and lines C and D. So lines A and E, they don't intersect right at that corner, so we had to approximate that answer there. And C and D, this point right here also doesn't meet at the corner, so you have to estimate your point there. And you should have noticed that there were some lines that don't exactly intersect on this graph. So lines A and D. This is line A, and this is line D. These lines don't intersect on this graph, so I'm going to write none. But lines C and lines E, they don't intersect right on this graph, but you can tell if we had extended this line up and E as well, they would intersect somewhere. So their point of intersection is just not on the graph, so you can either estimate that, but I'm just going to write not on the graph. So when you have the lines plotted out for you, you can just identify their point of intersection by looking at the graph and finding that point they intersect at. But graphing might not always be the best way to find the point of intersection, because sometimes by graphing you might have to approximate that point of intersection. There are other ways we're going to learn how to solve a linear system, but we'll do that in other lessons. So let's just move on to the next question. What is different about the solution for A and D? So this is where our solution for A and D is, and we wrote that there is no solution because these lines here on this graph do not intersect. So there is no solution. And then we're being asked to calculate the rate of change for lines A and D above. So let's go ahead and do that. Now you can use any method that you prefer. I'm going to just pick 2 points on each line and then count the rise and the run from those 2 points. So starting with line A, from this point down here, I would have to go up 1 and over 2. So I'm rising 1 and I'm running 2. So for line A, the rate of change, I'm just going to write slope here. The rate of change, or the slope, is 1 over 2. And then for line D, we'll do the same thing. So from this point right here, I'm going to go up 1 and I'm going to go over to the right 2. So for line D, the slope of this line is also 1 over 2. That rise over the run is 1 over 2. So what do you notice here? You should notice that we have the exact same rate of change, the same slope for both lines. So what does that mean when two lines have the same slope or the same rate of change? These two lines will never intersect. The slope of both lines is exactly the same, so they're at the same steepness, so they will never cross each other. So this is clearly different from lines A and lines C because their slope is clearly different and they definitely have a point of intersection. But lines A and D do not intersect, and when we do calculate the slope, they're exactly the same. So they will never intersect. So what that means is they are parallel. And that just means that the distance between these two lines are always going to be the same. So when two lines are parallel, they have the same slope. So let's just summarize our findings. So if we have intersecting lines, then let's just draw two lines that intersect. They have one solution, and that's just right here, the point where the two lines intersect each other. So again, there is only one solution. So an example of equations that could have a point of intersection could be y equals negative 2x plus 1 and 3x plus 1. And the main thing to point out here is that the slope, that coefficient in front of your x, is going to be different. If you have two lines that intersect, the slope has to be different. But if we have two lines that are parallel, these two lines will never intersect. The distance between the two lines is always going to be the same. So there will not be a solution to this linear system. And an example of equations might be y equals 1 over 2x plus 3 and 1 over 2x minus 1. So when you have two lines and you know that the slope is the same, exactly the same, then that means the lines are parallel and there will not be a solution. The two lines never intersect.